Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Model testing and validation processes. Model testing and validation are critical components of the AI development lifecycle, particularly within the phase of development and testing. These processes not only ensure that the AI models perform as intended, but also guarantee that they meet the required standards for deployment. The effectiveness of an AI model is determined by its ability to generalize well to new, unseen data. And this is where rigorous testing and validation come into play. Model testing involves evaluating the AI model's performance using a separate dataset that was not used during the training phase. This dataset, known as the test set, provides an unbiased evaluation of the model's ability to generalize. The primary goal of model testing is to identify any discrepancies between the model's behavior on training data versus unseen data. This process typically involves several metrics such as accuracy, precision, recall, F1 score, and area under the receiver operating characteristic curve, each providing different insights into the model's performance. For instance, while accuracy measures the proportion of correctly predicted instances, precision and recall provide a more nuanced understanding by evaluating the model's performance on positive and negative classes separately. Validation, on the other hand, is the process of tuning the AI model to optimize its performance. This involves dividing the dataset into a training set and a validation set. The model is trained on the training set, and its performance is validated on the validation set. This helps in fine-tuning the model's hyperparameters, the parameters that are set prior to the learning process and remain constant throughout. Techniques such as k-fold cross-validation are often employed to ensure that the model's performance is robust and not overly dependent on a particular subset of the data. In k-fold cross-validation, the dataset is divided into k subsets, and the model is trained and validated k times, each time using a different subset as the validation set and the remaining subsets as the training set. This method helps in mitigating the risk of overfitting, where the model performs well on the training data but poorly on unseen data. The importance of rigorous model testing and validation cannot be overstated. Inadequate testing can lead to models that perform well in controlled environments but fail in real-world applications. One stark example of this is Microsoft's Tay, an AI chatbot that was released on Twitter in 2016. Tay was designed to learn from interactions with users, but within 24 hours, it began generating inappropriate and offensive tweets due to insufficient testing and validation of its learning algorithms and user interaction models. This incident underscores the necessity of comprehensive testing to anticipate and mitigate potential issues. Moreover, ethical considerations and bias mitigation are integral to the testing and validation processes. AI models can inadvertently perpetuate and amplify biases present in the training data. Therefore, it is crucial to evaluate the model's performance across different demographic groups to ensure fairness and equity. For example, a study by Buolamwini and Gabru highlighted significant biases in commercial gender classification systems, which performed substantially worse on darker-skinned females compared to lighter-skinned males. Such findings stress the need for ethical rigor in the testing and validation phases to prevent discriminatory outcomes. Statistical rigor is another cornerstone of effective model testing and validation. Statistical hypothesis testing can be utilized to assess the significance of the model's performance improvements. For instance, the p-value can help determine whether the observed differences in performance metrics are statistically significant or merely due to random chance. This statistical grounding ensures that the conclusions drawn from the model's performance are robust and reliable. Furthermore, the integration of model testing and validation within the continuous integration and continuous deployment pipeline enhances the efficiency and reliability of AI systems. In a CI/CD pipeline, automated tests are run every time the code is updated, ensuring that any changes do not degrade the model's performance. This approach facilitates rapid development and deployment cycles while maintaining high standards of quality and performance. For example, companies like Google and Amazon have successfully implemented CI/CD pipelines to streamline their AI development processes, resulting in more reliable and scalable AI systems. In practice, the choice of testing and validation methods depends on the specific context and requirements of the AI project. For instance, in supervised learning tasks such as image classification, standard metrics like accuracy and F1 score are often sufficient. However, in more complex tasks such as natural language processing or reinforcement learning, additional metrics and methods may be necessary. For NLP tasks, metrics like BU score for machine translation or perplexity for language modeling are commonly used. In reinforcement learning, the model's performance is often evaluated based on cumulative rewards obtained in simulated environments. Another key aspect of model testing and validation is the handling of imbalanced datasets. In real-world scenarios, datasets are often imbalanced, meaning that some classes are underrepresented compared to others. This can lead to biased models that perform well on the majority class but poorly on the minority class. Techniques such as oversampling, undersampling, and the use of synthetic data generation methods like SMOT can help address this issue. Evaluating the model using metrics that are less sensitive to class imbalance, such as the area under the precision recall curve, is also recommended. The iterative nature of the model testing and validation processes is another critical consideration. AI model development is inherently iterative, requiring multiple cycles of training, testing, and validation to achieve optimal performance. Each iteration provides insights into the model's strengths and weaknesses, guiding further refinements. For example, if a model consistently underperforms on certain subsets of the data, targeted improvements such as feature engineering or data augmentation can be applied to address these issues. This iterative approach ensures that the model evolves to meet the desired performance standards. In conclusion, model testing and validation are indispensable components of the AI development lifecycle, ensuring that AI models are robust, reliable, and ethical. Through rigorous testing, validation, and continuous improvement, AI professionals can develop models that not only perform well in controlled settings, but also generalize effectively to real-world applications. The integration of statistical rigor, ethical considerations, and iterative refinement processes further enhances the quality and reliability of AI systems. By adhering to best practices in model testing and validation, AI practitioners can contribute to the development of trustworthy and impactful AI technologies. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.